This lesson is on chapter 13, volume. As you're probably aware, volume is simply the amount of space that something takes up. Whereas when we think of surface area, we think of how much it takes to cover something. With volume, we want to think of how much it takes to fill it up. Just as you learned surface area formulas for common solids, we're going to learn formulas for the volumes of those same solids. A prism is quite simple. If we're looking at a rectangular prism, you probably remember this from grade school. The volume is length times width times height. That is definitely the way to go if you have a rectangular prism. For other prisms, it's slightly more complicated, so we have a different formula. Namely, the volume of a prism is base times height. As I've made this point before, this is a capital B. It is not a linear measurement. Rather, it is the area of the entire base. In the case of this hexagonal prism, the area of the base would be the area of the hexagon, either the one at the bottom or the one at the top. The height is the distance between the bases. Volume of a triangular prism. Since we're working with a prism that's not a rectangular prism, I'm going to use this formula right here. Volume is base times height. Now, B stands for the area of the base, and because this is a triangular prism, the triangle is the base. The area of a triangle, I guess I could use capital A, or I could use capital B in this case. 1/2 times lowercase b, that's the base of the triangle, that's a linear measure, which is 10, times the height of the triangle, which is 12. So the area of the base, capital B, is 60. The height of the prism is simply the distance between the bases, which is 25. 100 times 15. Okay, so the volume of this is 1,500. And I do want to make the point that when we measure volume, it's cubic units instead of square units. Okay, as I've pointed out before, a cylinder is a lot like a prism. The only difference is its bases, instead of being polygons, are circles. We're actually going to use the same formula. Again, memorizing the formula for the volume of a cylinder is simple if you know the volume of a prism. So it's the area of the base. Well, the area of the base here, the base is a circle. Area of a circle is pi r squared. So when I fill in the formula for the volume of a cylinder, it's V equals pi r squared, and then the h. All right, simple example here. Volume equals pi r squared h. Pi, the radius is 1.8 centimeters squared, times the height, which is also 1.8 centimeters. I can't do that in my head, but the calculator is pretty good at it. I do want to make sure that you realize this is the radius of the base, this is the height of the cylinder. Okay, this is a right cylinder. Sometimes we'll be asked to do something slightly less boring than the examples we've just done. The volume of a cylinder is pi r squared h. Okay, pi times radius. They did not tell me the radius of this, the base of this cylinder. However, I noticed that this measurement and the height, along with the diameter of the circle, is a right triangle. And so if I want to know the diameter of this circle, I'm going to use the Pythagorean theorem. D squared plus 15 squared equals 17 squared. V is equal to 8. This is a pretty common Pythagorean triple. So the diameter is 8, and so the radius, therefore, which is half of the diameter, is going to be 4. So we're going to fill that in, 4 squared, and the height of the cylinder. Just because it's lying on the side doesn't matter. The height is still the distance between the bases. That's 15 feet. And yeah, another one for the calculator. Okay, this is Cavaliere's principle. It's very simple. All it tells us is that if a right cylinder and an oblique cylinder have the same radius as these two do and the same height, then they have the same volume. So if we want to find the volume of an oblique cylinder, we're just going to assume that it has the same volume of a right cylinder with a height of 25 and a radius of 15. So the volume of a cylinder is pi r squared h. Pi, the radius is 15, and the height is 25. again, plug into the calculator. All right, moving along. Pyramids and cones. Um, Pyramids are actually quite related to prisms. And in fact, if you were to take a square pyramid like this, and you could imagine turning another one upside down on top of it, and then filling in the sides with 4 more, you'd find out that 6 pyramids have the same volume as 2 prisms of the same dimensions. And therefore, the volume of one pyramid is a third of the volume of a prism. So it's just 1/3 base times height. You probably prefer writing it like this, although you could also write it like this. Whichever one of these you like best, feel free to use. 1/3 base times height. Find the volume of the square pyramid. Okay, I should point out slant height and height. When we were doing surface area, the only thing that mattered was the slant height, the slant height or the slant length. As we're doing volume, the only thing we care about is the height. We actually don't care about the slant height for volume. So, in this problem, they've given us the slant height, but we actually need the regular height. So, to do that, you'll notice, and this will be a frequent occurrence, we'll have to draw a right triangle. I know this side's 17. I want to know the height h. And you'll notice this is a square pyramid, so this is square. From the edge to the middle is going to be half of 16, so this side is 8. This is actually the same Pythagorean triple we had used on the previous page, so I know that h is 15. Okay, the volume of a pyramid is 1/3 base times height. And I'll go ahead and tell you the temptation. Somewhere you're going to see base, you're going to see the 16, and you're going to write it there. But, as I've told you, as I've stressed before, this is a capital B. It's the area of the base. It's not a linear measure. Well, they told us this is a square pyramid. If the sides are 16, then the area of the base is equal to 16 times 16. That's 256. So 1/3 times 256, and the height is 17. That's going to be a little bit ugly, and therefore I'm going to leave it for the calculator. A cone, okay? Just like we can find the area or the volume of a cylinder based on the formula for the volume of a prism, we can do the same thing with a cone and a pyramid. 1/3 is 1/3. The area of the base, well, the base is a circle, so its area is pi r squared. And then the height is the height. So this is our formula for the volume of a cone. All right, I was pretty straightforward here. Find the volume of the cone. V equals 1/3 pi r, which is 8, squared times the height, which is 18. That's 64. 384 times pi. I should have made this point earlier. Anytime pi is in your answer, you can leave your answer in terms of pi if you would like it to be relatively pretty. If you want to get an approximation, then plug it in your calculator. All right, finally, the volumes of spheres. We're not going to bother explaining where we get this, but here it is. It's 4/3 pi r cubed. You just have to remember that. It's easy to remember r cubed because we're doing volume, which is a cubic measure. Perhaps you remember the 4 from the surface area, and then the 3 is just like the 3 up there. Anyway, 4/3 pi r cubed. Just memorize that, and quite simply, the volume of a hemisphere is half that of a sphere, so it's 2/3 instead of 4/3 pi r cubed. A few problems. The volume of a sphere, I'm going to write down the formula, 4/3 pi r cubed. Maybe they're going to tell me, yep, they told me the radius, 15. Okay, as you're probably aware, 15 cubed is a very large number. You multiply that by 3 and multiply that by this, and you're going to get, again, a very large number. It's quite common when we do volume problems to get large numbers because we're multiplying 3 dimensions. The volume of a sphere. Again, the volume of the sphere. 4/3 pi r. They did not tell me the radius, so I'm going to have to use my formula. They did tell me the circumference. Well, the circumference of a circle, hopefully you've picked up on this by now, is 2 times pi times the radius. The circumference is 25. I find the radius by dividing by 2 pi. So the radius is 25 over 2 pi. I would probably approximate if I were you, or if you'd like a more exact answer, you can plug all of that into your calculator. Do not make the mistake of thinking these pi's cancel out, because the one on the bottom has to get cubed. But just get that in the calculator correct, you'll have the correct answer. All right, the volume of a hemisphere, I got this, 2/3 pi r cubed. If the diameter is 6, that means the radius is 3. Oh, I can actually do this one in my head. 27 times 2/3 is 18, so it's 18 pi. And that's going to be about 57. Finally, compare the volumes of a sphere and a cylinder with the same radius and height as the radius of the sphere. So the sphere has a radius of r. Well, I'm calling it r. If you would like, you could actually choose a number. And then I'm going to compare that with a cylinder whose radius is r and whose height is also r. So we have to compare the volumes of these. Well, the volume of a sphere, and I'm going to put a sphere here. The volume of a sphere is 4/3 pi r cubed. And since we said the radius is r, we're done. The volume of a cylinder, on the other hand, the volume of a cylinder is the area of the base, pi r squared, times the height, which is, okay, pi r squared each. So I remind you that in this particular instance, the height is r, so it's r squared times r, which is r cubed. So the volume of the sphere is 4/3 pi r cubed. The volume of the cylinder is 1 pi r cubed, or 3/3 pi r cubed. So clearly the sphere is larger. Let's see, it has 3/4 the volume? No. Has the same volume? No. It has 4/3 the volume. That's exactly right. 4/3 pi r cubed versus 1 pi r cubed. There we go. It does not have twice the volume.